The Kepler telescope was created specifically to gaze at a particular region of the Milky Way and look for exoplanets. Throughout the course of its career, the exoplanet hunter viewed hundreds of thousands of stars and found thousands of exoplanets. Exoplanets are planets that orbit stars outside our own solar system, and they have captured the imaginations of scientists and the public alike. The first confirmed detection of an exoplanet occurred in 1995, and since then, thousands more have been discovered. These discoveries have revolutionized our understanding of the universe and have opened up new possibilities for finding habitable worlds beyond our own. One of the most exciting aspects of exoplanets is the search for potentially habitable worlds. Another fascinating aspect of exoplanet research is the study of exoplanet atmospheres. By analyzing the light that passes through or reflects off an exoplanet's atmosphere, astronomers can learn about the composition of the atmosphere and even look for signs of life. Exoplanets come in a wide range of sizes and compositions. Some are giant gas planets like Jupiter, while others are rocky planets like Earth. Some are located close to their host star and have scorching hot temperatures, while others are located far away and have icy surfaces. However, out of all of these, one discovery is what scientists regard as the ultimate distinction, matching expectations and suitable for sustaining life. So where did the Kepler telescope find these planets in the region of space? What are their sizes, compositions, and atmospheres like? Will it really be possible for humans to survive there? You will get to know this and many more as we dive into the details of this outworldly being. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. The launch. Kepler was launched in 2009 as a component of NASA's Discovery program. Its task was to continuously search a set area of the Milky Way galaxy for planetary systems. It had the largest primary mirror ever sent into space and a 96-megapixel camera to process the light at the time of the launch. Finding out how many stars have planets orbiting around them and how many of these extrasolar planets or exoplanets have conditions that are favorable for the emergence of life was of interest to astronomers. Kepler spent 9 years in space, during which time it examined 530,536 stars and discovered 2,662 new exoplanets. There's nothing like these exoplanets that we have ever seen in our solar system. There are some very strange worlds, some of which have star-facing sides with temperatures that can melt iron and have entire hemispheres covered in oceans of liquid molten rock. The majority of these worlds are significantly larger than Earth and orbit their stars so closely that they complete one revolution every few days. Some Jupiter-sized exoplanets orbit not one, but 2 stars. You could observe a binary sunset if you were standing on the surface of one of these planets. Kepler's legacy, however, is the discovery of Earth-sized planets orbiting safely apart from their host stars within the so-called habitable zone or Goldilocks zone. Here, the temperatures are just right for water to condense on their surfaces without being too chilly to cause it to completely freeze. Water is an important element and the basis of life as we know it, even though being in this zone does not guarantee the existence of life. One of the most significant discoveries made by Kepler was the prevalence of small rocky planets. Prior to Kepler, we had no idea how common Earth-like planets were in the galaxy. Thanks to Kepler, we now know that they are quite common. In fact, it is estimated that there may be as many as 10 billion Earth-like planets in our galaxy alone. This has greatly increased our optimism for the existence of extraterrestrial life. Kepler also provided us with valuable information about the size, mass, and orbit of exoplanets. By observing the light from stars as planets pass in front of them, Kepler was able to detect the size of the planet relative to the star, as well as its orbital period. By combining this information with follow-up observations from other telescopes, we were able to determine the mass and density of many exoplanets. This has helped us to better understand the composition and structure of these planets. Perhaps the most exciting discovery made by Kepler was the detection of potentially habitable exoplanets. These are planets that are located in the habitable zone of their host star, where conditions may be suitable for liquid water to exist on the surface. Liquid water is considered to be a key ingredient for life as we know it, so the discovery of potentially habitable exoplanets is of great interest to astrobiologists. Let's take a closer look at some of the most notable exoplanet discoveries made by Kepler. Kepler 10b. This was the first confirmed rocky exoplanet discovered by Kepler. It is about 1.4 times the size of Earth and orbits very close to its host star, completing one orbit in just 0.84 days. Kepler 22b. This was the first confirmed exoplanet discovered by Kepler that is located in the habitable zone of its host star. It is about 2.4 times the size of Earth and orbits its host star in 290 days. Kepler 186f. This exoplanet is about the same size as Earth and is located in the habitable zone of its host star. It is notable for being the first Earth-sized exoplanet discovered in the habitable zone of its host star. Kepler 438b. This exoplanet is about 1.1 times the size of Earth and is located in the habitable zone of its host star. It is one of the most Earth-like exoplanets discovered by Kepler to date. Kepler 452b. This exoplanet is about 1.6 times the size of Earth and is located in the habitable zone of its host star. It is notable for being the most Earth-like exoplanet discovered in terms of size, mass, and temperature. Kepler 296e. This planet is located about 1,200 light-years away from Earth, and it is believed to be a rocky Earth-like planet that is about 1.8 times the size of Earth. It orbits a star that is cooler and smaller than the Sun and is located in the habitable zone of its star. After 9 years of groundbreaking discoveries, the Kepler Space Telescope officially retired on October 30, 2018. The decision to retire the telescope was made after it had run out of fuel necessary for its scientific operations. Despite the end of its mission, Kepler's legacy will live on for many years to come. Its data will continue to be analyzed and studied by astronomers and astrobiologists around the world, providing valuable insights into the nature and diversity of exoplanets and planetary systems. In fact, it is estimated that there are still thousands of potential exoplanet discoveries waiting to be made within the massive amounts of data collected by the telescope. Kepler's retirement also marked the end of an era of exoplanet exploration. While other telescopes such as TESS and the upcoming James Webb Space Telescope will continue to search for exoplanets, Kepler will always hold a special place in the history of exoplanet science. Its discoveries have fundamentally changed our understanding of the cosmos and have brought us one step closer to answering the age-old question, are we alone in the universe? Proxima Centauri. The Proxima Centauri system is a triple star system located in the Alpha Centauri star system, which is the closest star system to our own. The system is composed of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Proxima Centauri is the smallest of the 3 stars, with a mass of only about 0.12 solar masses, and is a red dwarf star. It has a surface temperature of about 3050 Kelvin, 2777 Celsius, or 5030 Fahrenheit, and a luminosity of only about 0.15% that of the Sun. It is located about 4.24 light-years away from Earth and is the closest star to our solar system. The 2 larger stars in the Alpha Centauri system, Alpha Centauri A and Alpha Centauri B, are binary stars that orbit each other closely. They have masses similar to that of the Sun and are both similar in size and temperature. Alpha Centauri A is slightly larger and brighter than Alpha Centauri B, and both stars are much brighter than Proxima Centauri. Proxima Centauri is known to have at least one exoplanet in its orbit, which is called Proxima b. This exoplanet, as mentioned earlier, was discovered in 2016 and is a potentially habitable world located in the star's habitable zone. Proxima b has a mass that is at least 1.17 times that of Earth and orbits this star at a distance of about 0.05 astronomical units, which is much closer than the Earth is to the Sun. The Proxima Centauri system is a fascinating target for astronomers due to its close proximity and the potential for habitable worlds around its stars. The discovery of Proxima b has generated significant interest in the system and could help pave the way for future exploration and discoveries in the search for extraterrestrial life. One of the primary goals of the JWST is to search for and study exoplanets, planets outside of our solar system, and determine their potential for habitability. One of the most promising exoplanets in our immediate vicinity is Proxima b, located just 4.2 light-years away in the Alpha Centauri star system. Proxima b is an exoplanet that orbits the red dwarf star Proxima Centauri, the closest star to our solar system. The discovery of Proxima b was a significant scientific breakthrough, as it was the closest exoplanet to Earth that was potentially habitable, with a similar size and orbit to Earth. The discovery of Proxima b was made using the radial velocity method, also known as the Doppler spectroscopy technique. This method involves measuring the periodic variations in a star's radial velocity caused by the gravitational pull of an orbiting planet. In the case of Proxima b, astronomers observed Proxima Centauri using the High-Accuracy Radial Velocity Planet Searcher (HARPS) spectrograph at the La Silla Observatory in Chile. Over a period of several years, they detected periodic variations in the star's radial velocity that indicated the presence of an orbiting planet. The data from these observations were analyzed to determine the planet's mass and orbit, as well as its potential habitability. Further observations were made using other telescopes, such as the Atacama Large Millimeter-Submillimeter Array ALMA. These observations provided additional evidence that the planet was likely a rocky world with its mass similar to that of Earth. Scientists also used the transit method to indirectly confirm the planet's existence. This method involves observing a star's brightness over time and looking for small dips in brightness that occur when an orbiting planet passes in front of the star. Using this method, astronomers observed a small dip in Proxima Centauri's brightness that was consistent with the presence of an orbiting planet. Overall, the discovery of Proxima b was the result of a collaborative effort between astronomers using a variety of observational techniques and instruments to gather evidence of the planet's existence. The discovery has opened up new possibilities for the search for life beyond our solar system.